In this video, we will be discussing the law of reflection. When a ray of light is reflected from a smooth surface, the angle of incidence is equal to the angle of reflection. This is most commonly referred to as the law of reflection. Consider the following diagram. The blue rectangle represents a mirror. The dashed line creates a 90-degree angle to the mirror, which represents the reference point. An incident ray strikes the mirror. The reflected ray bounces off the mirror. As a result, this demonstrates how the angle of incidence is equal to the angle of reflection. Now for the actual experiment.
The laser was placed on the first track. The two mirrors were taped so that they were at a right angle to each other. Then the dihedron of mirrors was placed at the end of the track opposite the laser. The white screen was placed adjacent to the laser on a second track. Once the laser beam was turned on, flour was dusted over the laser beam to make the beams visible. In our experiment, the reflected beam always emerged parallel to the incident beam. This relationship is justified by the law of reflection and some simple geometry. If we draw the two mirrors, making the horizontal mirror the x-axis and the vertical mirror the y-axis, we can plot the beams on a Cartesian plane. We have defined positive x to be to the right and positive y to be up. If we define the incident angle for mirror 1 as theta 1 and 90 minus theta 1 as theta 2, we can fill in all of the angles on the reflected beam using triangle geometry. If we consider the beams of light as vectors, then the I, J, K notations for the incident beam and the reflected beam are these equations. For any value of theta, the two vectors will have the same magnitude but opposite directions, creating two parallel beams just as our experiment showed.